So, how would you solve this? First, we're going to write down what we know. We know the outer lengths of the kite. We want to know the inner lengths of the kite. In order to do that, we need to break it up into separate triangles. The separated triangles, we can solve for the x, y, and z component using the Pythagorean theorem. We now have an equation for the y and z component. Now we write out the equations for all the separate triangles. Since we are trying to maximize the area of the kite, we need to find an equation that represents the area only using one variable. We know the equation for the area of a triangle. Since there are 4 triangles, now replace base and height with labeled variables. Now try to simplify as much as possible. To make the equation all one variable, we substitute y and z with the equations we found. Find the derivative and find the maximum value at that one variable. We use the product and chain rule to solve for the derivative of the area. Now we try to find a common denominator. We try to find a common denominator to make this all one fraction.
Derivative of the area is 4 minus 2x squared multiplied by the root of 16 minus x squared plus 16 minus 2x squared multiplied by the square root of 4 minus 2x squared all over root 4 minus x squared multiplied by root 16 minus x squared.
Now we are going to try to maximize the x length. To do that, we are going to make the derivative of the area equation equal 0. This equation is a fraction, therefore we are only going to focus on the numerator. This can be done algebraically or graphically. However, we are going to do it graphically because solving it algebraically is a pain.
In order to solve it algebraically, we need to put this equation into a graphing calculator. And when you put it in a graphing calculator, you come up with a graph that looks something like that. And then when you put it